sulfur dioxide. Then preparation. Okay, so it can be prepared by burning sulfur. If you burn sulfur, if you burn it, you get here SO. But molecular sulfur formula is what? S8, rhombic sulfur, rhombic. So here you will write 8, it will be 8 sulfur dioxide. B. It can be obtained by the reaction of bisulfide and sulfite. See the spelling, ITE. Salts with acids. Okay. So you have taken here potassium bisulfite. See. Potassium bisulfite is used in the preservation of food. Remember. So to that, if suppose if you add HCl, so you will get here potassium chloride, H2O, and sulfur dioxide. If you have added, if you have taken sodium sulfite, I don't know what I'm doing these days. Writing wrong formula. Na2SO3 plus if you have added sulfuric acid, so you will get now here sodium sulfate, H2O, and sulfur dioxide. So generally prepare sulfur dioxide in laboratory by this method because it's not good to burn sulfur because sulfur gas is very heavy and it will be difficult for you to breathe and it's toxic also. So by this method we can prepare sulfur. Okay. So properties. Physical. It is colorless, heavy gas. So how do you know it is heavy? You can find its density. Density, you can find it theoretically. What about the molecular mass is there? Half of it is density. So molecular mass of sulfur dioxide is 64 divided by 2 is 32. So it is much, much heavier than air. Air is 14.4. So wherever sulfur dioxide will be there, it will displace air from that place. With a smell of rotten egg. Okay, it is highly soluble in water. reaction with water. Sulfur dioxide reacts with water to form sulfurous acid. So we got sulfurous acid. Reaction with bases. See here. Sodium hydroxide reacts with sulfur dioxide to form Na2SO3 H2O. If sulfur dioxide is passed through long time Na2SO3 reacts with it to form sodium hydrogen sulfide. Okay, so I'll write this equation again. I'll write now here 2NOH plus SO2 will give you Na2SO3 plus H2O. So this Na2SO3 again reacts with sulfur dioxide to give you 2Na8SO. So if I add it, it will be like this. So this and this will get cancelled. So you get now here 2Na8, 2SO2 will give you 2Na8SO. Now I'm going to write one more for your entrance exam. So first you finish it. I'll explain, then you write. Okay. So anyway, this is not in your book. Third, sulfur dioxide turns blue litmus paper red, and finally colorless. Means what? It becomes white. Why it is like this? We'll write now here. So I'll write here now. One more word I was supposed to write. turns moist. Means you have to wet it. Turns moist, blue litmus paper red, and finally divides. Sulfur dioxide turns moist blue litmus paper red because it reacts with the water present in moist litmus paper and form sulfuric acid. You know, acid always turns blue litmus paper red. Okay. The red color of the litmus paper become colorless because sulfur dioxide bleaches the write down or bleaches the sulfur dioxide is strong bleaching agent. So this is for your entrance.
Done, sir.
Okay. See, okay. See, in the preparation of sulfur dioxide, one thing I forgot to tell you is what? That if you go for roasting of sulfide ore, this is one of the commercial process of preparation of sulfur dioxide. We roast any sulfide ore. If you roast, you know the equation also. It gives us metal oxides and sulfur dioxide. Okay. Now we'll do some addition reactions. See, remember, addition reaction product is only one. See, sulfur dioxide, oxygen. You get it as vanadium pentoxide as catalyst. Okay, you will get here sulfur dioxide. So it's only one product. So these type of reactions are called addition. Or you can say oxidation of sulfur dioxide. Now, sulfur chlorine. If you heat it, you get SO2Cl2. This is called sulfuryl chloride. SOCl2 is called phenyl chloride. SO2Cl2 is called sulfuryl chloride.
Done, sir.
Okay, now sulfur dioxide is mostly used for reduction. So now we'll do reduction rate. sulfur dioxide is mostly used for reduction. See, sulfur shows an oxidation state of -2, 0, +2, +4, +6. And as I told you that when you go down the group, higher oxidation state is less stable. That is, the elements on the top, they are more stable in highest oxidation state. So in sulfur dioxide, sulfur has an oxidation state of +4. So it will be more stable in +6. So in that case, it is going to lose 2 electrons to attain more stable oxidation state because it has minimum inert pair effect. All right. So anything which liberates electron, they are called reducing. Okay. Sulfur dioxide reduces in presence of moisture. See, litmus paper will what decolorize. In presence of moisture or in water. So let me tell you how does it happen. See here, I'll write down. Sulfur dioxide 2H2O gives you H2SO4 plus 2 hydrogen. This is called nascent hydrogen. Nascent hydrogen. This is the hydrogen which reduces the other chemicals. Here oxidation state of sulfur is +4. Here oxidation state of sulfur is +6. So this is our conventional equation. So let me write its ion electron equation. So I'll write now here. It is ion electron equation. You'll find this equation is much better for you to understand. See here. Sulfur dioxide, it is plus. What it will give us? It will give us sulfuric acid. Sulfuric acid will ionize to give you 2H plus and SO4 2 minus. So we are supposed to write ion. So I'll write now here SO4 2 minus. All right. So here it is +6. So how many electrons it has lost? 6 electrons. Here you have 2 oxygen. Here you have 4 oxygen. So where from you will get now extra 2 oxygen from this water, 2 molecules of water. So now when these 2 molecules of oxygen and 2 becomes 4, what is left out? Hydrogen. So this is the one that you get here. So this is our conventional equation. This is our ion electron method equation. So often sulfur dioxide is being used for reduction purpose.
Done, sir.
Okay. So now in your book only 2 equations are being given. So I shall restrict myself to 2. Right now here. It reduces ferric sulfate. What is the formula of ferric sulfate? Fe2 SO4 sides to ferrous sulfate or ferric ion Fe3 plus 2 ferrocide. Fe2. Okay, so I'm going to do this equation in 2 ways. So I'll write now. SO2 plus 2H2O giving us H2SO4 plus 2 hydrogen. Now ferric sulfate, and it already we know it gives us ferrous sulfate. All right, now see how many iron are there? 2. Then I will write here. How many sulfates are there? Left hand side 3. Here you have 2. So what will happen to the other sulfate? So let me write here SO4. For SO4 as an ion, it is not stable. So what should I write now here? 2 H. This one. I'll write down here H2. This by adding this and this will get cancelled. So what should you write now here? Fe2 SO4 3, then 2H2O plus SO2 will give us 2FeSO4 plus 2. So this way we will do. Now we'll go for ion electrometer. So right now I have or. So here I'm going to write SO2, 2H2O, 4H plus, SO4, 2 minus, 2 electron. Just now see we have written. Sulfur dioxide does not reduce sulfate, it reduces only iron. So in ferric sulfate, oxidation state of iron is +3. And what you get here now? Fe2 plus. So it is going to take 1 electron. We'll get this. How many electrons giving? 2. Electron always has to be balanced because all chemical reactions are electrically neutral. So this and this will get cancelled. See here, we'll get the same thing. 2 Fe3 plus, see here, 2. Then 2H2O, 2H2O, SO2, then 2 Fe2 plus C2, 2 ferrous, and 4H plus and SO4. 2. So try to do by this method, you will not make any mistake. Otherwise, these are difficult for you to balance.
Done, sir.
Okay. Now I'm going to do the most important reaction of this sulfur dioxide. Right. When sulfur dioxide gas is passed through acidified KMnO4 solution, how does it look like? Deep purple. Sorry, I'll write here. Deep highlight. When sulfur dioxide gas is passed through acidified KMnO4 solution, turns it colorless. So let me do it. Here I am going for ion electron method. If I go for conventional equation, that it will be extremely confusing for. Okay. So I write now here SO2, 2H2O, giving us 4H plus, SO4 2 minus. See now, this is manganese. What from potassium? Formula of potassium permanganate is KMnO4. So it is going to react with manganate, which is violet in color, and it become colorless. So it forms always in acidic condition. This is +7 and this is +2. So this is colorless and this is violet. All right, see here. What is the difference between +7 and +2? 5 electron. So it is going to take 5 electron. Who is supplying? This first step will supply. Now, here you have 4 oxygen, here you do not. All the oxygens are being converted into water. So I'll write down here 8H plus. So I'll write now here it is 4H2. Number of electron gain and loss should be equal. So this is 5 and this is 2. So they are not, you cannot multiply and make them equal. So what should you do? You should go for cross multiplication. 5 and this will multiply by 2. Okay. So I'll write now here 2 KMnO4. This is +4. So here finally we will not write the oxidation. All right. 5SO2. I am going to write things which are appearing in both the steps. I will not write. Think which is only once, that I am going to write to balance. So it will be 2Mn2 plus 5SO4. Now see what are the things are appearing on both sides. See here. Here you have 8 into 2, 16. 16H plus. And here you have 5 into 4, 20H plus. So that it is more. So it will go to this side. So 20 minus 16 is 4. Well, right now here 4H. Now how many water you have on the right hand side? It is 8. And this is what? 10. So 10 minus 8 is 2. Okay. So here I will write here now 5. And here I will write color. Right? And after that I'll write one sentence. What is
Done, sir.
okay. So now we'll go for the application set. Here. Sulfur dioxide is a bleaching. What is the meaning of bleaching agent? What is the meaning of bleaching? What is the meaning of bleach? Do you know the meaning of bleach? Huh?
Sir, removing stain or something?
No, to remove color. Your stain is having a color, so you have to remove it. So bleach is to remove any color. Whether it is some gravy is fallen in your cloth, because of that you have a yellow stain, or suppose suppose you are going for a painting a picture, say your black color or red color has fallen in your garments. If you remove that one, that is also called bleach. So sulfur dye is a bleaching. It bleaches only in presence of moisture or water. It bleaches by no dry sulfur dioxide does not. Now, why it requires moisture or it has to be done in water? See here. Just now the equation that I have written, SO2, 2H2O, giving us sulfuric acid and 2 hydrogen. So this is the nascent hydrogen which bleaches. And nascent hydrogen will be produced only when it comes in contact with water. So we write now here the nascent hydrogen produced in the in presence of water bleaches the color. Okay, so I'll write this equation again. SO2, 2H2O, H2SO4, 2 hydrogen. Then I'll write them now. Colored substance. It can be anything. Plus 2H. It will become colorless. So this is the chemical equation for bleaching.
Done, sir.
Okay. So now, here's a very important thing is there. Bleaching action of sulfur dioxide is not permanent. It is very strange. Suppose you want to bleach your cloth, you have bleached it, it has become white. After some day again, you find that the color is reappearing. Now, why it is like this? Why the color got bleached? Because of the height. This height. See, when you use this cloth again, this cloth comes in contact with the atmosphere. Hello. Thank you. Thank you. Link. Na বানাইছি না এখনো বানাই তুই বানাইলা বানাই পাঠিয়ে দি আমি আসলে ক্লাস নিলাম ও 6টা 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 15 অব্দি ক্লাস নিলাম তুই লোক বানাই পাঠাতে তো আমার সুবিধা হইল শুন তুই তো তেড়াতের মাঝে তোর কিছু বানাইতে পারে Okay. Now when you wash your cloth, keep it for drying, it comes in contact with the air. And air you have oxygen. Yeah. This oxygen reacts with the hydrogen that is present in the cloth. And by the way, hydrogen goes out. When the hydrogen goes out, again the color reappears. So what should you write? Bleaching action of alpha is not permanent. So if you explain it, we'll write here. It is because the hydrogen which bleach the color react with the oxygen present in atmosphere in presence of sunlight and get removed. So the color reappears. So in that case, will you bleach your cloth by sulfur dioxide?
No, sir.
Then what will you bleach? Cloth we use it for long time. Suppose the different color of the shoes that you wear, that shoes also, that is not the color of the leather. So leather is bleached. After that, the color is being colored. So will you bleach your leather item? Will you bleach paper? Why you do not bleach them? Because we use it for long time. So what type of substances we should bleach with sulfur dioxide? Suggest. I told you the substances which you use it for long time, we do not bleach with sulfur dioxide. Then what type of substances you will bleach with sulfur dioxide? You can't guess. So we'll write now here. Thus, the articles which have long shelf, SHLF, shelf life, means which you use it for long time, are not bleached by sulfur dioxide. This is our experience. Then what for you should bleach? So it is used to bleach those substances which has short shelf life. Okay. Example, food items. If food items are made, do you keep it for a long time? It will get spoiled. So, food items such as sugar. See, sugar you get it from what? Where from you get sugar?
Sugar cane.
Huh?
Sugar cane.
Sugar cane. Sugar cane juice, if you concentrate, will you get colorless sugar? If you concentrate sugar cane juice, you will get brown sugar or you will get jaggery. So, what you do after crushing the sugar cane juice, before you concentrate, you pass sulfur dioxide through it. Then the juice become crystal clear. From there, we concentrate and crystallize sugar. Okay. You can use bleach flour. You can bleach fruit juice. Etc. So will you bleach orange juice by sulfur dioxide? Hello.
Yes, sir.
If orange juice becomes colorless, will anyone buy?
No, sir.
But will you buy colorless orange juice? So you can bleach lemon juice because lemon juice is colorless. But when you make juice, some sort of color impurities comes from it. So people will say that it is dirty. So they will bleach it. So those citrus fruit which are colorless, we bleach it with sulfur dioxide. Oh. To wrap the board is becoming so hard for me now. So now we'll go to sulfuric acid. Sulfuric. Okay. We'll go for directly inductive. We'll go for manufacture. Manufacture by contact process. Okay. We manufacture sulfuric acid from sulfur dioxide. Okay. So it involves, I'll write only the equation. Involves the following steps. So now, 1. Generation of sulfur dioxide. Generation of sulfur dioxide You know it, how can you get it? You can get it by burning sulfur. If you burn it, you get here or by what? Roasting of sulfides. Suppose you have taken here copper pyrite, you get here now Cu2O. This sulfur dioxide, which you come from metallurgical industries, earlier used to release in the air, we don't these days we don't release because it causes acid rain. Suppose you have done for zinc sulfide, you get here zinc oxide and sulfur dioxide. See, this sulfur dioxide, if you may not prepare sulfuric acid, but you can sell it. Second, conversion of sulfur dioxide to sulfur dioxide. The sulfur dioxide so obtained is purified by washing with water because it's totally free from dust, otherwise it's going to spoil our catalyst. By washing it with water and dry. It is then passed over vanadium pentoxide catalyst under 2 to 3 atmosphere at 725 Kelvin. What is going to happen? 2 sulfur dioxide plus O2. Please remember this is reversible reaction and exothermic. Which is vanadium pentoxide 725 Kelvin 2 to 3 atmosphere. It will give you 2 sulfur dioxide. And the reaction is exothermic. Mole inverse. Third, conversion of SO3 to H2S2O7. Now see, don't write. See, SO3, if I simply dissolve in water, then I get H2SO4. Our purpose is to get sulfuric acid. Then why you are not dissolve it in water? To directly get sulfuric acid, there is a technical reason there. So I'll write now. This sulfur trioxide gas is not directly absorbed in water to get H2SO4. Yes, the reaction produces tremendous amount of heat by which a dense fog of H2SO4 is created. Who created? This is extremely harmful. Okay. Hence, it is absorbed in concentrated H2SO4 to form H2S2O7. So this is known as oleum. So you get here now H2SO4 SO3 gives to H2S2O7. Oleum. This is important for your exam. Question may be asked, why sulfur trioxide is not dissolved in water to get sulfuric acid? So you have to write. Because this is going to create problem for the machines as well as for human being who is working there. Now, 4. Conversion of H2S2O7 oleum to H2SO4. The oleum is diluted with water to get desired concentration of H2SO4. Suppose you want to get concentrated, you add less water. If you want to get dilute, if you add more water. So right now here, H2, S2O7, H2O will give you 2H2SO. So this is the story of sulfuric acid. Preparation of sulfuric acid. Okay, now finish it. Then I'll tell you how to improve the yield. Finished?
So done.
Okay. Now the thing which I'm going to write, this is the one generally being asked in the exam. how to improve the yield of H2SO. So first you write the preparation of sulfur trioxide from sulfur dioxide is a reversible and exothermic process. So right now here 2SO2 plus O2 V2O5 725 Kelvin 223 atmosphere 2SO3 delta H is minus 196 point how much? 196.6 or what? Just now you've written na?
Yes, sir.
6 kilojoule molecules. The yield of sulfur dioxide, see, ultimately from here only you are getting sulfuric acid. So if this is more, sulfuric acid is also more. The yield of sulfur dioxide can be improved by Le Chatelier's principle. This you have to write. What other things are there? See, any reversible reaction which is exothermic, if you want to get more yield, temperature should be less. Otherwise, if you increase the temperature, then the reaction will move from right to left. Then this will be less. Yield will be less. So what we will write now here? The effect of temperature. You write the reaction is exothermic. So in order to improve the yield of sulfur dioxide, the reaction must be carried out at lower thus an optimum temperature of 725 Kelvin is maintained. Okay. Now we'll write effect of pressure. See, any reversible reaction, if you carry out, look at the volume of the gas that you use. 2 plus 1, 3 volume. Here you got 2 volume. So there is a reduction in the volume of the yield. In such cases, the equilibrium can be shifted towards right-hand side of product if you carry out under high pressure. The formation of sulfur trioxide leads to reduction in volume. So, to get more yield of sulfur dioxide, the reaction must be carried out under higher pressure. Thus, the pressure of 2 to 3 atmosphere is maintained. For MBO student, this is going to come next year. I'm telling you, 90% chance. So now we'll go to the third part. Third is the effect of catalyst. The yield of sulfur trioxide is increased by the use of vanadium pentoxide as catalyst. This is enough. Now, care should be taken about the purity of sulfur dioxide gas. Here what? It is free from dust particles. Otherwise, it will poison the yeast. So this much if you write, you are going to get 2 marks. And if you write the equation you have to first you have to write, and followed by this, you get 3 marks. So now we'll go to the properties of sulfuric acid. Finished?
Yes, sir.
Okay. Now we'll go for properties. Sulfuric acid is colorless, highly viscous, it's very heavy. Its high viscosity is because of the presence of intermolecular hydrogen bond. This is sulfuric. Okay. So now we'll have see all the molecules are closely linked, and that makes it highly viscous.
Done, sir.
Okay. See, dilution of concentrated H2SO4 with water is highly exothermic. Means what? It produces tremendous amount of heat. Water should not be added to concentrated H2SO4 as it liberates huge amount of heat, and sometime may sometime explode. Excuse me. হ্যালো, শুভ জন্মদিন। আচ্ছা, হ্যাঁ, আচ্ছা আচ্ছা। না, পটল ভাত খাইতে খাইতে এখন বাহা খুঁজেন পটল আনতাম না। ঠিক আছে, আমি ক্লাসও okay, sometime explode. Hence, to dilute acid is added dropwise, ulta, to cold water with constant style. So sometimes you use it, you work in the lab, you be careful.
Done, sir.
Very good. You are only simply writing, and if you don't understand, then also you don't ask me. Remain like this. Do whatever you like. Okay, now. B, chemical properties. Chemical properties of H2SO4 can be classified into 4 categories. Okay. All right. I'll write now here. A, S, and acid. B, as a non-volatile acid. Non-volatile means like HCl and nitric acid, it does not evaporate. C, as a dehydrating agent. In your book also they given it like D, as an oxidizing agent.
Done, sir.
Okay. So now we'll do this one. We'll write now here H2SO4 is a strong dibasic acid and it dissociates stepwise. Okay, so I'll draw it like this. I'll draw it like this. See, wherever oxygen hydrogen bond is there, that is going to break. That we have seen in case of the acids of phosphorus. So one of the first one will break. Once this breaks, you get what you will get now here. HSO4 minus and H plus. So this is very fast. Then one more is there. So I'll write now here. This is this. So you will get now here SO4 2 minus H plus. This is low. Because of that, sulfuric acid forms 2 types of salt.
Done, sir.
So we'll write here now. Therefore, H2SO4 forms two types of salt. First, we'll write now here hydrogen sulfate salt. This is known as acid salt. Why? Because still it has a ring and hydrogen. And sulfate salt. Okay. So what we call it? Normal salt. Okay. So I'll do the reaction. If you have taken one equivalent of sodium hydroxide, you get now here NaH SO4. This is one we call it sodium hydrogen sulfate. This is also known as sodium bisulfate. This is common. See, it is still having a hydrogen which can go out. Because of that, we call it to be acids. And if you have taken two equivalents, then you will get here sodium this is sodium sulfate. This is called normal which are not having hydrogen. So as an acid, it will react with salt bases to form salt and water. So right now here reacts with bases to form corresponding sulfate salt. So sodium hydroxide already you have written. So now you can take here calcium oxide H2SO4. It will give you calcium sulfate, water. It will react with sodium carbonate. It will give you sodium sulfate, water, carbon dioxide. It is going to react with bicarbonate. So you will get here K2SO4, 2H2O, SO4, 2 carbon dioxide. It will react with ammonia to H2SO4 to form ammonium sulfate.
Done, sir.
Okay. So now we'll go for the next one. Next one is as a non-volatile acid. As a non-volatile is highly viscous. Even if you boil also, vapor will not go. Concentrated H2SO4 is non-volatile. Hence, it is used to prepare different volatile or gaseous compounds in pure state. Right. Example, suppose I have taken sodium chloride and I have taken here concentrated H2SO4. And if I heat it below 420 Kelvin, I will get here sodium hydrogen sulfate and HCl gas, pure form. Similarly, if I have taken sodium, if I have taken here calcium fluoride, and if I heat it with concentrated sulfuric acid, here I'll get calcium sulfate and hydrofluoric acid. Hydrofluoric acid is prepared in this way. This is the laboratory as well as industrial preparation of HCl, hydrogen chloride gas. If I heat sodium nitrate and concentrated H2SO4, and here also if I heat it below 420 Kelvin, I'll get here sodium hydrogen sulfate and vapor of nitric acid.
Done, sir.
Okay. Next is third. As a dehydrating agent. Dehydrating agent means which will absorb water. Hello, Chantuda. Hello. হ্যাঁ লিংক লিংক 7টার মধ্যে লিংক পাঠাই আমার ক্লাস আছে হ্যাঁ ঠিক আছে okay now what is dehydrating agent? A substance which can absorb water. So what we can write here? Concentrated H2SO4 is a strong dehydrating agent and absorbs water from wet substances. water of crystallization. What is wet substances? Which contains water. What is water of crystallization? That substance is not wet, but water is being bonded to crystallization. And removes water from those substances which contain hydrogen and oxygen in the ratio of what? I'll show you. Don't get scared. See here. This is not in your book. Copper sulfate 5H2O. We call it green, blue vitriol. This is not wet, but is bonded to. So it is blue. True that if you add concentrated H2SO4, it's not reacting, it is taking water. What will happen now? Copper sulfate 5H2O. See, it becomes white. This water is being absorbed by sulfate. You should know. Now, let me take this. C12H22O11. See, this is sugar. In water, the ratio of hydrogen and oxygen is 2:1. See, it is 2:1. So, if you have dropped sugar in concentrated H2SO4, you know sugar is colorless. You will find at the bottom of the test tube, you are getting some yellow powder. This is called what? Carbon. This is called carbon. So, colorless substance has become black as if it has got burned. So, what we can call it? This reaction is called CHRRING, charring of sugar. This is given in a book. So now in exam, instead of this, they give you glucose. Same thing. What will happen here? There will be 6 carbon and 6 molecule of water. One reaction which is there, which is not being given in your book, no problem. This is called formic acid. It is an organic acid. This is the acid. Honeybee, when it stings, it gives you supply you this acid. See, in this case, there are 2 hydrogen and 2 oxygen. So what can happen? This can go. So what you can write now here? Concentrated H2SO4. You will get now here water plus carbon monoxide. So I'll do one more. Suppose you have taken oxalic acid. Oxalic acid, you get it plant oxalis. Okay. So now what is going to happen? See here. The compound will break down. So here you will get water, carbon monoxide, and carbon dioxide. This is carbon monoxide, carbon dioxide. এটা মেশিনে ঢুকাই তো বেশি ঢুকবি।
Done, sir.
Okay, so I will not extend it.